the teachers. Among all, the National Science Fair is, by the grace of Allah, it is popular nationwide. Alhamdulillah, we have conducted as of now the 14 science fairs. Inshallah, we are now planning for the 15th science fair. As you all aware, science fair is not a science exhibition. In the science fair, the student will display the projects. That is a research-based project. The projects that are done following the scientific methodology. Since the concept is new, a student may not prepare the project as per the scientific methodology. So every year before the science fair, very well in advance, we conduct training workshop to the teachers, like what we are going to have today. And in this training workshop, our aim is to train the teacher to know about the scientific methodology with the various illustration of the science fair project. The objective is to enable the teacher to guide the student to do the science fair project, research-based science fair project, following the scientific methodology. That is the objective. And now we have planned a series of webinars on Saturdays. The first is today we have now by Dr. Qazi Azher. Now I request our Joint Secretary, Brother Khatib, Anif Khatib Sahib, to welcome the gathering.
नहमदुहु व नुसल्ली अला रसूलिहिल करीम अम्मा बाद रब्बि इश्रह ली सदरी व यस्सिर ली अमरी वहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली. Chief guest of the evening, Dr. Qazi Azher Sahib, Dr. Peshman Nazir Ahmad Sahib, Joint Secretary OMIAT, Dr. A. Nigar Akhtar, Joint Secretary OMIAT, and Dr. Abdul Kamal Nasir Sahib, who's our, I can say, the Ruh Rawa of this science fair, and respected teachers who are participating on the webinar on preparation of science fair projects in relation to National Science Fair 22-23. Assalamu alaikum wa rahmatullahi wa barakatuh. It's my proud privilege to welcome you all on this webinar, which as Professor Abdul Kamal Nasir was mentioning, is being conducted to train the teachers for the conduct of science fair, which will be inshallah our 15th science fair. 14 science fairs we already successfully conducted in our previous years, and all these have been in association with our Dr. Qazi Azher Sahib, who is Associate Professor of Michigan University, United Nations of America, and who does not need any introduction whatsoever at all. Alhamdulillah, he has been associated with us right from the beginning. And in fact, I will not be wrong if I say that on his advice and his unseen sisters only, OMIAT started conducting science fairs. Alhamdulillah. So, मैं समी में क़ल्ब से आपका इस्तक़बाल करता हूँ, डॉक्टर साहब. I welcome all the teachers who have joined here today. I was very happy to know that 79 participants will be there today, inshallah, and some have joined and some are still joining. So I'm happy with the number of participants. in spite of the fact that, the holidays are just over and the colleges and schools are just opening. But in spite of that, you have taken time to join this, and your interest should be appreciated. So, welcoming all these people, of course, I don't have to talk about the Qazi Azher Saab. Like I said, he doesn't need any introduction whatsoever. But our Dr. Peshmam Nazir Sahib will be introducing Dr. Qazi Saab in detail after me. So, once again, I welcome you all to this webinar, which is on preparation of science fair projects. One and all, I would like to mention all the names, but the time doesn't allow me. I consider this project a very important one, because here you will be trained, the teachers will be trained how to go, how about to go and prepare the students for the science fair. So that way it's going to be very important. With these few words, I welcome one and all and say Assalamu alaikum wa rahmatullahi wa barakatuh.
Jazakallah khair, Khatib Sahab. Alhamdulillah, today all over India, the science fair is prevalent and popularly conducted. It is because of the initiative and guidance by Dr. Qazi Azher, with whose guidance we started in 2008, and now Telangana Science Fair Academy and Karnataka Science Fair Academy, Andhra Pradesh Science Fair Academy and Maharashtra Science Fair Academy have come up, and every year science fair is conducted at various regions, and the National Science Fair is conducted in Chennai. Now the brain behind the whole program, Dr. Qazi Azher, will be introduced by our Joint Secretary, Dr. Peshman Nazir Musa.
Assalamu alaikum wa rahmatullahi wa barakatuhu. Nahamadu wa nusalli ala Rasulil Kareem. Rabbi Ashri Sadli. Just now, Mr. Khatib Saab has said that Dr. Azher Saab needs no introduction. Yes, of course, Dr. Qazi Azher needs no introduction. He is well known to not only at the national level, but at the international level as a well-known figure, mashallah. But there are a few teachers among us, there are new entrants, and definitely it is my bounden duty to introduce him. He is, mashallah, his qualification BSc BEd, MD, FCAP, FASCP, and apart from that, he is the Associate Clinical Professor, Michigan State University, Lansing, Michigan, Secretary, Genesee County Medical University, Flint, Michigan, Chairman, Scientific Review Committee, Flint General Science Fair, Flint, Michigan, Director and Clinical Advisor, Baker College of West of Michigan, Director, Digestive Disease and Nutrition Center, Burton, Michigan, Vice Chairman, Department of Pathology, Hurley Medical Center, Flint, Michigan. Apart from that, his really small portfolio, I'm telling, his profile runs for pages and pages. If you just click the Google, you will understand. But for as a duty, I'm telling only a few things here. Always he is interested in the field of education, even after acquiring degrees in medicine. He is one of the handful in the world who has qualified in medicine as well as education. MashaAllah. Being associated with medicine, took a special interest in neuroscience and brain-based education. Kept abreast with the modern research-based methodologies in teaching and learning. Member of National Research-based methodologies in teaching and learning. Member of National Science Teacher Association and Association of Supervision and Curriculum Development. Apart from that, founding member and secretary, Genesee Academy, Flint, Michigan, USA. Moreover, Chairman, Scientific Research Committee, Flint Regional Science Fair, Michigan, USA. Author of the book, A Guide to the Science and Engineering Fair. Moreover, author of the lesson 8th standard book of Andhra Pradesh and Telangana, How Scientists Work. Apart from that, mashallah, Allah inko nazar bas se bachaye. He is a lesson. He has written a lesson in the 4th grade science book published by MFRD, that is Millet Foundation for Research and Education, development. Moreover, conducted seminars and workshops for Council of Science and Technology, State of Tamil Nadu, Andhra Pradesh, and Jammu and Kashmir, number of other states in India. Conducted seminars and workshops for SCRT, State Council of Educational Research and Development, Andhra Pradesh and Telangana. However, is established state and national level science fairs in Tamil Nadu, Telangana, and is still going on doing his human service to number of students in India. He has written numerous English and Urdu articles about modern methodologies of teaching and learning and importance of scientific investigation. Conducted national and international level seminars on science of learning, science of teaching, and science of scientific investigation. Moreover, he has conducted CME workshop for pathologists and postgraduate students in Department of Pathology in various medical colleges all over India. However, he is so much interested that involved in teaching brain-based education, science of learning and teaching, hands-on inquiry-based pathology, research-based teaching techniques, and science of scientific investigation. Apart from that, he is the whole and soul, and is the brain behind all the science fairs being conducted at national and international level. Moreover, he is the spirit of our Ummah, Organization of Muslim Education Associations of Tamil Nadu. Because of him, he added a feather to us that Ummah is marching for a better tomorrow and producing junior scientists in number of fields. MashaAllah, the list is still going on, but however, I am limiting to this. Please, you click the Google, you will understand more about him. Let me conclude with this while introducing you, sir. If anything there apart from it, please excuse me, sir. Thank you, sir. Well,
Jazakallah khair. Alhamdulillah, very vast introduction. Alhamdulillah. Now over to Dr. Qazi Azher for his presentation.
A'udhu billahi minash shaitani rajim. Bismillahir rahmanir rahim. All right. Can you see my PowerPoint?
Yes, sir.
yes, yes.
Thank you. A'udhu billahi minash shaitani rajim. Bismillahir rahmanir rahim. Alhamdulillahi rabbil alameen. As-salatu was-salamu ala rasulihil kareem. Assalamu alaikum to all, and particularly the organization of this series of seminars by Umayyad. And I would like to thank Dr. Peshmam Nazir Sahab, who is the president of Umayyad now, and Dr. Nigar Akhtar, Dr. Miran Sahab, and of course, our favorite, Dr. Nazir Sahab. So with this, without further ado, I will start my talk. Need for, this is a kind of very important presentation which I'm going to address today. Need for integrating academic and research at school level, science fair as a tool. So we all know now, we are very familiar with science fair, and we always promote science fair, and we discourage science exhibition, and all the developed countries do not promote or do not have science exhibitions. If there are some exhibits, they may be in the classroom, but not in anywhere. When it comes to science competitions, science fair is the only science competition at the regional, at the school level, at the regional level, at the county level, at the state level, and at the national level and international level. So somehow we have to understand the reason why developed countries do not promote science exhibition. And this is the concept I was trying to promote for last more than 30 years in India. And it is taking time, but Alhamdulillah, now a lot of states have started this, and we have at the Indian national level, IRIS, and our science fair, participant can, participate also in IRIS, and through IRIS, you can come to International Science Fair, which is every year conducted in America. And you can win up to $75,000 and win scholarships in various schools like Harvard, John Hopkins, you name it. So let's talk about why we have to integrate, the scientific research into school curriculum. So our education system in India has not advanced very well, even though you can see here in ancient time, there was a teacher in front, and instead of having the bottom picture, you could see nice desk and uniform, students are in uniform, and we have digitalized the blackboard, but still they have the same kind of, book to write, a little bit advanced, though at that time there were plaques or slates of stones they used to write. And the same concept is there. Teacher in front, and the students are listening to teacher and observing the teacher, what she's saying. And all these kids are silent. And in fact, I always tell in my seminars, we tell our students pin drop silence. So the same thing. And if now, this is the picture I'm giving you. It's happening a mat, that's fine. But it's still, instead of having that stone plaques or slates, they are having these paper notebooks, which they use a more modernized pencil or pen to write. So the concept remains the same. So we are educating our youths the same way we did 100 years ago. So another thing I would like to say that science is research. Without research, you cannot have a scientific science. So it is very important, and it should be a part of academics. Academics, when we say academy, it includes research into it. If you Google it or go to the dictionaries of what is science, what is academy, what is academics, and what is academia. Academia comes from the word academy, AK in that, from Greek word. It includes all the areas of education system itself. The teachers could be professors, lecturers, and schools, colleges, universities, everything. This is all academia, along with a subtype, which is research in this academia. So research plays an important role in academia. But unfortunately, this research has been forgotten in Indian curriculum, whether it is in the schools, colleges, or even at the university level, unless you do PhD. But it will be quite interesting that particularly the science subject, we cannot teach to the student without making them understand what is scientific research. And you may ask me, what is science? Science is the systemic study of the nature. You look around, there is science everywhere. You can see here, I have a microscope in my office. We have a scanner, digital scanner. I cannot show you here. I have phone, I have computer, I have this cell phone, and there are many things. I have the chair, I'm sitting and I have a table which is designed very nicely. Chair is very comfortable. So it is the study of science which has come up with all these gadgets and all the tools we are using, all the comforting equipments, articles, all those. And even we are holding the pen, and this is also the great invention of science. So science starts with curiosity. When you look at, oh my God, there is a mountain. I see all the time rocks on there. What happens to those rocks? Can they fall? Can they roll down from the mountain? This is just the curiosity and a question. And this observation lead to noticing something is happening. What happens to the snow collected on the mountains? And can we, does this snow slides? Same thing with the mud. If there is a lot of dirt on hills and mountains, do they slide? And has any time this thing has happened? All those curiosity observation leads to experimentation. You want to do some kind of experiment and see what happens. So that is science. It is part of science. Science is carrying out investigation. When you are doing experimentation, you are investigating something. It's like a CID. You have a very good you have a very good show in India, CID. That is investigation. There is a person who does investigation, and scientist is the one who does investigation. So science is discovery. Remember this. If you don't want to memorize the whole definition of science, just remember science is discovery and engineering is invention. And engineering leads to development of technology and inventions. So science is testing hypotheses too. Science is testing hypotheses. What is hypothesis? Sometimes we use this word. No, what you are thinking is hypothetical. That means you are thinking, you are postulating, you are, sometimes you can say, you are thinking, but without any evidence. So science is always evidence-based. So if you have a hypothesis or a logical prediction that if I do this will happen, it will lead to this. It will, I will come up with this answer. This is the solution of the problem. So that is your hypothesis, but you have to somehow make this prediction true, make it authentic, make your hypothesis an authentic scientific fact, and that will lead to the principles of science. So discovery leads to the science is discovery, and discovery leads to engineering and technology. I will give an example. For example, Watson Crick's they discovered DNA, and now we have a technology developed in forensic medicine called DNA fingerprinting. So this technology will let you know the blood which was found at the crime scene. Whose blood is this? We do DNA fingerprinting, Western blot. I don't want to go in detail, just want to remain at the common understanding level. So, and then you can test the blood sample of that crime scene and also the suspect who has done that, you think who has done it. And if these DNA samples match, you got the good evidence. So this is evidence-based medicine, forensic pathology, which is a part of science, okay? And science, engineering and technology. So science is testing hypothesis, and science predicts. The weatherman, when he comes on TV, he says that tomorrow there is going to be rain. How does this happen? He is using science. He is using the data. He has analyzed what happens when these clouds, which are moving in this direction and reaching Chennai on that day, and how many of these clouds on the way will rain, and how many will reach to Chennai, and whether there will be rain or not. The same thing we can predict. The wind, how fast the wind is blowing. So all these are predictions you can have from the science. Science is, as I mentioned initially, you cannot take scientific research from the science. Research is part of science. It's a soul. You cannot take out the soul from the body. If you want to see this is active and helping the mankind and bring new technologies, we have to discover. The science is the discovery, and this discovery leads to inventions. So science is based on research. What we do in research, we analyze, we collect data, we have the results, and results show us the data, and at the end, we analyze the data and come up with conclusion. Well, what happens to the salt when it gets mixed up with the water? Why the sea salt? The sea has a salty taste. So you come up and why people in a certain ocean cannot drown? What is there? And when you taste, oh my God, the water is so salty, you can't even put a drop of water on your tongue. And now the people are not swimming, but they are floating in that water, in that ocean. You know what ocean I'm talking about. So you can do this kind, observation is there, but you can test this observation in your lab. You can investigate, collect the data, and then come up with conclusion. Oh my God, the highest amount of salt in that ocean is making the things float, even the human being. So that is science. If we have to teach science, teach with the investigational aspect as well. So that is research, as the title today mentions, that we need investigational component, and science fair are investigational. They are research based, and without research you cannot do science fair projects. And with that, I'm going to advance a little bit. So what those students in our classrooms were doing, you could have seen there was a teacher on a nice digital board, and she was explaining about science, and students were listening, and sometimes they open the book and they read the science. That's not science. That's not how you learn science. You learn science by doing science. That is very important. And we want to promote the educational departments should build a curriculum, science curriculum, which let them do the science. And ultimately, when you do anything, like when students play games, sports, they love it. Why? They are doing it. They are not reading sports. They are not reading how to play games, and playing games on computer is kind of okay, but not as hands-on. So again, we have to develop a curriculum which is hands-on, inquiry-based. When I say inquiry-based, it is research-based. Remember this. This is research-based. We have to completely revamp the syllabus. Indian syllabus. We think that we are the best. It's okay to call, we are shining, we are the best. But are you really the best? That's what it matters. So this make science fun. So I will talk about three-dimensional learning in next generation science standard. I'm going to talk next generation science standard later on. And yet, a lot of people have copied, for last 30 years, copied my slides, copied my talks, but not yet anybody copied next generation science standards, because I have not presented. This will be the first time I will give you glimpses of next generation science standard. This is the most advanced type of teaching and learning and America has started. And almost, I know this last 10 years, but now almost all states have adopted next generation science standard, a way how the student learn. I am not going to say teach, learn. That's how the students learn, and they enjoy it. So the traditional method of science lesson is teacher teach content. Content is the curriculum, the syllabus, what you have. And lesson 1, lesson 2, what is in lesson 1, you teach. These are content. So they teach the content, the core curriculum. Well, then the students are expected to learn the key features of those contents. So gravitational force, they have to learn, and they teach it, and they memorize. This happens in English medium or any medium. So the mother tongue medium schools are a little better because they can understand in their own language, whereas English medium students kind of memorize the stuff, and right from the kindergarten they start memorizing like poems. I'm not going to go in detail. Students later do confirmatory lab by doing activity. So when they go into higher grades, or maybe in high school or in colleges, now even in high school, they don't do science. So first, the teachers tell about theory. What is behind this law of motions? They talk law of motion 1, 2, and 3. And the kids memorize it. And there is no experimentation in it. But there are few, for example, how to make hydrogen gas. So they will, in the chemistry lab, first they will, with the formulas and all the, they will show, the teacher will teach how the hydrogen gas is produced. Okay. Well, you take HNO3, nitric acid, sulfuric acid, hydrochloric acid, all that has H in it. They will teach you like this. H in it. What is H? H is hydrogen. So they will put HCl, or take any zinc, for example, zinc. Now they will put an equation mark, and they will say, this is, it splits where there is a reaction between zinc, which is a metal, and this acid, which is inorganic acid, and you will see zinc chloride, and hydrogen is released. And then they will also show how to equate the equation, balance the equation. So with all that, and then many a times they just leave it. They don't even do, I see now even at the college level, the laboratories have become a kind of museums, and which has not even used at all. But there are some what they call good colleges where they teach theory and teach practical. That's the way our old system is. Now everything has changed. In three-dimensional learning, in next generation science standard, content and labs are taught together. And this is not taught, sorry to say that. They are done by the students together. They are one who are going to find out what happens. They are the one who is going at the end of their learning process. They will find out how the hydrogen was released, how they found out that this is hydrogen, it's not oxygen, it's not nitrogen, it's not carbon dioxide. They learn while they are doing it. Nobody teaches them. This is, I'm just giving an example in higher grade. In lower grade, this is the same thing. Roll a ball. What happens to the ball? Is it going in a straight line? Is it kind of deviating its course? What made it to deviate? What made it to slow down? All that thing kids do. Children are doing in the classroom and then writing down on a piece of paper or a notebook. So we now forgot how to write. This is the biggest problem what we are facing now. So in next generation science standards, our students learn by doing, with their curiosity, experimentation, with their investigational, natural, innate quality. So those are the things which are very important in learning process. And this learning, you don't have to memorize. And we have to build a school system which dwells on this type of learning methodology. Just saying we are good, we are doing this, oh, English medium is this good, that. Science is a thought process. Science is not language. Remember this, it is very important to learn in mother tongue. Later on, you can learn as many languages as you want. And believe me, this is also a science, and this is also research-based and evidence-based. Those students who learn in their mother tongue will excel in learning the foreign languages. Not one. You don't have to learn only English. English is not science. So this is what I'm trying to stress today. But let's go back. So a student learn content are not in isolation. In our traditional method, we were learning in isolation. By the time you start doing practicals, you have forgotten the theory which has been taught to you. So our students learn at the same time. So this is very important. And I want to show you the three-dimensional concept of next generation science standard. Integration of, three aspects of science is very important. What are those? Practice, you can say, see here, practices, content, cross-cutting. What is practices? There are two practices, science and engineering. These are the methodology, the science behind this. We do the research, the scientific research, okay? One is for discovery, other is for invention. So we adopt two methods, scientific method and engineering method. Scientific method to discover, We adopted scientific method to discover many things, like cell has a nucleus, cell has a DNA. So that was a discovery based on a tool, which was an engineering tool, was microscope. You can see in the background, I have the microscope. So I look at the cells and come up with the diagnosis and discover whether this patient has cancer or no cancer. This patient has blood cancer, or just the number of cells have increased because of infection. So all those, so we use certain practices, and there are two practices: scientific method and engineering method. And I'm not going to go in detail because next sessions will teach you more about those. I'm just going to give you the basic idea why research, scientific research, is essential in our classrooms. So the next one is content. As I mentioned, content is your syllabus, curriculum, the core curriculum. And like, you learn sound. So sound has lessons in it. So that is part of curriculum. Magnetism and electricity. This is a topic in the science. It has so many lessons. So this is content, or the curriculum, the core concept of this curriculum. Okay, and then what is cross-cutting? Cross-cutting is, we see, there was a time when we studied a lot of subjects in isolation, like botany was taught different, chemistry was taught different, medicine was taught different, and physics was taught different. Engineering and technology was taught different. Still we have different colleges. Yes, specialization, you can, but at the school level, we should teach them, making the students understand, not teach them, learn. They should learn it in a way that all these subjects are not in isolation, but they are overlapping. They merge into each other. There is integration. So that is cross-cutting. So when you are learning biology, you are also learning chemistry, what happens in the biology. So I'm just giving you an example. And this is what it means. This is how science is done in the real world. And this intertwining make the students learn science or even other subjects better. And to tell you honestly, other subjects are also, I think I have one slide about that. I'm going to talk on that. So the meaningful learning occurs when you learn any subject with research in mind. Whether adults or children, they have the same basic innate property in them, innate nature, built-in nature in them, in our brain. Our brain is curious. That curiosity leads to question, and that question leads to a hypothesis. I think, when I will throw a heavier ball and a lighter ball, heavier ball falls faster than the lighter ball. So this is your hypothesis. So what you will do? You do experimentation and let the student do the experimentation and let them solve this problem, come up with their ideas and how they are going to devise the experiment, design the experiment, and make a protocol of the prototype of the experimentation, and do experiment on that prototype in engineering method. So all these are very important aspects of learning. Then only meaningful learning occurs. you can see the definition. This is what should be in our curriculum, school curriculum. And of course, we are going to learn more if I talk, or maybe somebody else will talk, how to do instruction in this environment of curiosity, inquiry-based, hands-on learning process. So how we should do the assessment. This is a whole lot a different game. And it doesn't come by copying somebody's curriculum. Like new education policy is almost copy of the American system of, but still they have not copied next generation. They did mention that, we should have activity-based learning. And what is this activity-based learning? Making a model, drawing some pictures on the board. What is this activity? We are not talking about that activity. We are talking about research-based activity, how scientists work. That's the way science should be learned. Well, I think I talked more about this cross-cutting concepts and content. Cross-cutting concept is they learn all the aspects of science together. And even with the art subject also, we say social sciences, isn't it? So why? Because there is anthropology. And then you have in that economics. So recently, one of Indian, the scientist, economist, got Nobel Prize, and he used scientific method in that. He did trials, like how vaccines have a trial, 1, 2, 3, 4. He did trials. So he used, the science is not restricted to only science subjects. It overlaps. It overlaps with the art subjects. What you think art subject, they are not anymore art subjects. Education itself is science of education. It's not art subject. It's not art of learning and teaching. It is science of learning and teaching. And this concept I gave long time back. I conducted many seminars on this. And now it is neuroscience of learning and teaching. So the knowledge changes. And with knowledge, education changes. And we have to cope up with that education. It is very important part. And we are teaching our, our teachers are learning from old system. We are following up, as I showed in this picture, in the initial picture, how we how this has continued, and still it is there. And when they talk about quality of education in India, oh, English medium has the best quality. What kind of quality? If the kids are not understanding, they are memorizing. What kind of quality? Speaking in English a few words doesn't make them scientists. That's why we didn't receive any Nobel Prize after independence of India in science. That's where that the government has to think about this. That education department has to think about it and try to learn from the developed countries what they are doing different than us. So just copying doesn't matter. Okay. And as I mentioned about dimension 1, which is science and engineering practices. So the three aspects of 3 dimension. One is practice. The other one is cross-cutting. The third one is content, isn't it? So with that, let's see, how these dimensions display in various science disciplinary courses. If you look at science, it's not like a vast subject. It's just simple, and we make it complicated. What is that? There is physical science, there is life science, there is earth and space or environmental science. And then we added now in next generation science standard, engineering, technology, and its application. Beautiful, isn't it? You may ask me, well, when do you teach all these topics, all these subjects? We teach right from kindergarten. Oh my God, engineering and technology in kindergarten? Are you crazy? No, we are not crazy. We will teach them according to their understanding and brain capacity. When a ball rolls on the ground, there is an engineering behind it. The smoother the ball, the company which was made, the smoother, the surface is smooth, it rolls better. That is engineering. They will come to know what happens to a rough ball. Will it go that far? A ball with a rough surface, will it roll that back? That is engineering. How to make ball. A kid automatically, believe or not, I see all the time in my grandkids and my kids when they were young, they will find the ways how this thing works better. And they will do in that way. What is that? What is how they are solving the problems? Remember, engineering starts with problem. And science starts with observation and a question comes. So science is discovered. The question comes, well, what makes this plant not doing well? And you try to find out, you try to discover. So that is science. Well, and what makes this plant grow faster? You think, so you develop fertilizers. And developing fertilizer, solving that problem is a part of engineering. You have a big machine which does everything. We mix up all these things and try to come up with the best product of fertilizer. So that is science, okay? That's engineering. So we teach this right from the kindergarten. And the best part is the kids do it. Children do it and learn it. And that way, we don't have to memorize anything. Everything is in the brain. They grab it. And that's why I always show the picture that the brain has the largest portion is the hand. And we are teaching our kids not to use the hand. It's again, I'm telling you the science behind it. So all these things, for example, physical science. What is physical science? Only four things in physical science: matter and how matters interact. That's it. One, and motion, because we are moving, mobility, forces, what motions does and what forces does. Forces and motion are integrated, intertwining. And when you use a pushing force, what happens to the ball? I'm just using ball today. So it is easy, isn't it? So what happens to the soccer player, you call football, and the ball is there, and unless somebody kicks, it is remain in a stationary position. So that's how we have to teach science, whether it is kindergarten or whether it is in 12th grade, whether it is in college or university, anywhere. I was surprised the universities do not have a very elaborate laboratories, not even working pH meter. They don't know how to standardize, the pH meter. This is something we have to think about it. And just having colleges, numerous universities doesn't mean anything. We need quality. Quantity doesn't matter. So that is what I'm trying to tell you. And then energy. Well, Energy comes in various forms. And then waves, like sound waves, water waves, what? That's it. Your physical science is done. And let the kids do projects on each of them and learn what is matter, how matters interact. Let them work on motion and forces and find out, how this motion and forces interact, and the energy, various types of energy, how you can save energy. Let them do a project on this. And same thing with sound and waves, electrical waves, and all those. So this is the whole physics I'm telling you. And this could be learned effectively by something called, I'm going to introduce this project-based learning we call PBL. It is not same as activity-based learning. Remember this. And a lot of directors of education do not understand this. And those who developed and copied the curriculum, science curriculum, new education policy, syllabus, and all those things, all those policies are of no use when you do not know how to implement them, how they work. So I hope after this, my presentation on next generation science standard, the science to be learned in this way. And life science is the same, space science is the same, environmental, earth science. So the last one is engineering and technology. So basically, science starts with scientific inquiry, and engineering is a designing process. Engineering is invention. I'm not going to go in detail. And so we formed next generation in a syllabus, people a short form, because I'm giving you the a brief view how we standardize, or we can call these are the benchmarks. These are the tools. How much to be taught in what classes? This is important. Some of the private schools, I will not reveal the names. They advertise everywhere. They try to teach. Engineers have become PhDs in psychology when neuroscience is there. So, what I'm trying to tell is just not copying and just, you cannot copy a curriculum and put it together. You have to understand the basics of it. You can teach kindergarten students and first grade students up to a certain extent. And this is what we call benchmark. And you have to follow those standards. These marks are called standards. And these standards have to follow. That's why first standard, we say first standard, because the brain of that first grade, which is about 6 years old, and even in that, the one who is early 6 and the one who is in late 6 age, they understand differently. So what we teach them should be understandable to them. So this is what we call brain-based, and next generation standard depends on brain-based education. So for example, this is life science, LS means 1, from molecule. Look at this, this is primary school in here, isn't it? So you are teaching at primary school level. This is the standard. All organisms have external parts. Different animals use their body parts in different ways. All right. And they see, hear, grasp, and protect themselves, move from place to place. And plants may not move, but they can stretch out and while they grow and take in food, water, air, plants, and all those kinds of things. The LS1, that elementary school curriculum should have that much. You cannot talk about internal organs in there. This is important. And They learn by doing this science. They actually pick up a flower. Each students go to the garden, and you make a field trip. That's why everybody talks about Finland. In Finland, students spend more time outside these classrooms than inside. And they follow the American brain-based, inquiry-based learning. Research is done here. We take more time because each state has its own rules. To adapt that rules, it takes time. So other countries, smaller countries, quickly adopted that, and they are on the top. Look at now, Finland is no more on the top in PISA score. Hong Kong is on top. China is doing much better than any other countries. It's amazing. And there was a time when India and China were at the same level. And how they picked up fast, because they are not putting their brains on unnecessary things. They are putting their brains on education. They have a big budget for education. Just copying a curriculum and putting it in our system doesn't work. How you are going to implement, how you are going to make all those teachers who are trained in that. You have to change the B.Ed, M.Ed, and D.Ed courses. Their syllabus, their content should be changed and modernized. Well, it takes a lot of time. Where are you going to bring those professors who are going to teach them? A lot of money, billions of dollars. We are spending money on wrong things. We are not spending. The most important part of country budget should be on education, particularly those developing countries. So what I'm trying to say is and of course, when you go in high school, you talk about DNA. You are talking about the genes, how the genes are made up, all those things. So, and again, I will give, this was done in 1999. Can you believe this? And we are talking about now. And this was a research article. And what about physical science? I told you about the forces and all those things. Look at this. There are three aspects which were researched. And what is the number? The dark black line here, the graphic line, even before instruction. So you started a subject on, for example, force. And how much students knew? Almost not even 10%, or you can say 10%. And then when you taught them with traditional method, what? Students in front, teacher in front, and the students are sitting there and learning, whether it is in college or in the school. How much they learn? Well, almost about 22%. And when they did by themselves and learn, look at this. Wow. On an average, 80%. I'm sure there are many more 100%. This is the way we have to teach. We have to introduce our project-based learning and science fairs in our educational system so that they do science fair projects are nothing but project-based learning. This is very important part I'm trying to, and you know, the other thing, it came to my mind, how we try to improve our student learning by conducting memorization gimmicks. There are some so-called experts who come to your school. There are two experts. Do not allow them. The one who talked about memory and I'm going to improve your students' memory, it has not worked. Otherwise, students will have 100%. Your school will have 100%, 100% scores in all the subject, in all the 100% students. Those are gimmicks. Don't waste money on that. And then the other one is motivational speakers. Put the sign, motivational speakers are banned from this place. how the motivation takes place? By doing the things. That produces internal motivation. External motivation doesn't work. It has never worked. GM, which where the motivational speeches and all those tricks were done, they stopped doing this. So schools don't allow them. People are paying. I come and teach, I don't take a penny. And these guys come and you pay them 2 lakhs for what? Give me money, I will do something for your school. I will spend the same money on your school, on your laboratory, on the project-based learning. I will teach your teachers. I will spend that money on your school. So this is what I'm trying to tell you. Acceleration. Look at this. Everybody who is doing hands-on by doing a new method, the experimental method or hands-on inquiry-based or research-based method, they are learning in, this is a very good graph. Okay. So there are 2, as I mentioned. Please let me know when the time is over. Okay. Integrating science fair with science curriculum. People think that, oh, you know what? It is easy to make models. Overnight, we can make a model of a volcano or a dam, or can make, use magnetism and make an electric bell and all those things. Or put a slide with some organisms, paramecium, and show under the microscope. Well, it's okay. You do it in your classroom. That's fine. But when you do a project-based learning, you are doing a research. And through the research, or when you are doing a science fair project, you are doing a research. Project-based learning is part of the curriculum. You have to convert your whole syllabus into project-based learning. It's not easy. I think recording has stopped. It says, can anybody let me know? Shall I continue?
Yes, sir. Another 10 minutes.
Yes, sir. Continue, sir, please.
Okay.
Yes, sir.
All right. So this is the very important conclusion part I'm giving you. So project-based learning, we have to convert. And those schools, you will hear Shamim Raja, she has done some work on that, and they are my students. Same way, Dr. Okay, thank you. Same way, Ghafoor Madam and Shamim Raja and other, they are working on it. And in Gulbarga, most recently, Naveed Anjum Madam and Rajgiri, Rashmi Rajgiri, and they got the ideas, and inshallah very soon we are going to do project-based learning. So we will come up with some, we will videograph the students doing project-based learning as a model to you, and you can take on from there. And same thing, science fair done out of your curriculum. But people think that, no, this is not in our syllabus. No, that is not right. When you do a science fair project, you learn mathematics, you learn algebra, you learn calculation, you learn various others, you learn how to write. It's part of your syllabus. A scientist is a good writer, because when these students do project, they write down their observation. They write down how they did the experiment. They write down what are the materials they took in this, and they put in sentences. So they are learning your language, mother tongue, English, or whatever. So they are learning the language too. So it is just not out of syllabus. It is part of syllabus. When they are working on motion, is some kind of a project, and they are learning about the law of motions. So that is important. And it is just not, I will show you in some of these projects. For example, these are the high school students who are doing a project-based learning. They are given a project that look at this pond. There is a water here in front, and they are taking water and screening them and see what, and taking it to the laboratory and looking in, is there any life in this pond? What organisms have in this pond? What is the surface of the water? How many planktons are there? How many microorganisms? Is there any paramecium in there? So they are testing this, and they are also testing the water. What kind of toxicity it has? Are there any chemicals? Is there any industrial, where these chemicals are coming from? They check the draining water streams. Is there any industrial waste dumped into that stream? They check all that. What they are learning what they have to learn in the classroom. So this is multi-dimensional learning, and this learning is best because you integrate life science with the chemistry, because in the pond there is chemistry. They will check the oxygen level. They will check the pH of the pond. So they are all learning this. And we want our students to learn this way. So science fair and project-based learning are all the same. And here, these are the teachers. These are the teachers who are learning that car. When you pull the car, it goes, because it has elastic wire, it has coil inside. So when you are pulling that, is that elasticity make the car go in one direction? How far? And what are the variables that are affecting on the wheels of the car itself? All those things. They will learn what is independent variable, what is dependent variable by project-based learning and by science fair projects. So that is where, science exhibition, nothing. Universities are doing science congress. Oh, what they bring. Congress. I went to so many science congresses and so many science exhibits in India. I was just bringing models, saying and they memorized in English, all those kinds of things, and they kind of vomit out everything in front of the judges. Once they, in between you stop them, same thing as they are doing with the science fair. So let them speak in their own language. Let them talk what they have done. They will tell you. So all those things. So, and they will come up with the data and interpret the data okay. Now, quickly, our all the classes or the grades, right from the 4th grade onward to the college, they all have important thing. You can see that what tools do scientists use and all those, what is the scientific method and how they observe and put a question and form a hypothesis, all those, plan an experiment, conduct experiment. So all those things, and at the end was the conclusion. At the end was conclusion and results. So this girl, she worked on the effect of course, this is not in India. This is in my science fair, in Flint Regional Science Fair. She did a science fair project on surface chemistry on pond water. She tried to find out, was there any acid rain here in this area? Because the industry is so close. She checked on the water surface and the chemistry, and look at the organisms and look at the chemical content of that pond water. So all that, and this is our Flint area regional science fair. See, there is no model in front of it. Every kid has done. See, they don't put model. This kid has done something, bitterness and sweet, and tried to look at the organisms, cultured it, what the sweet, how much the sweet, it could be sweet product of any kind, can grow bacteria. And if there is more acidic, drinks, I put and cultured that and saw that what happens. So this is all scientific research. I'm not going to go over each and every project, and we do not allow exhibits, and our OMIA Science Fair do not allow any exhibits or models. And this is the National Science Fair. I would like you to come over here and win scholarships and the prizes. The grand prize could be $75,000, and it's a lot of money, particularly when our dollar is value of rupees is going down and dollar is going. So 75,000, you could imagine, how much money that will be. And Harvard could offer you a scholarship and take you, and same way the other institution. So with that, I conclude. Thank you very much. If you have any questions, please ask me the questions.
Thank you, sir. Alhamdulillah, very wonderful, impressive talk with emotions. It is not just a speech. Alhamdulillah. And now open to our participants. Any question you can take. Participant who want to raise any question, you can. Dr. Qazi Azher, as yes, anyone?
Please feel free to ask me question. I gave you, I don't know how many hours I cut off.
Yeah. Nearly 1 hour, sir.
Yeah, good.
Alhamdulillah, your talk was very impressive, and you have revealed how the research is the soul of science, and one has to learn science by doing, and you clearly initiated how the research can be integrated in academic with the NGSS, the next generation standard. You revealed. Anyone question? Anyone? You can unmute and ask question, or you can put it in chat also.
Please ask the question. Even you can do it in chat.
Yeah.
Or the hand.
You need to learn and teach science with research in mind. You have to be very curious. The curious mind will raise questions. Okay, sir. Wonderful talk. Jazakallah khair, sir. And I would like to make a very important announcement. This is a series of webinar we have started today. We will have the 4 sessions on consecutive Saturdays, not next Saturday. Next Saturday we are leaving in view of Eid al-Adha, the Bakrid festival.
There are some
next webinar will be on 16th July by Mr. Shamim Raja. She will talk on scientific methodology and the preparation of science fair projects in physical science on next webinar, that is on July 16th, inshallah. Someone wanted to say something. Anyone?
I think there is some
there is one question in the chat box, sir. That is few questions are, since the science, the syllabus is vast, how to incorporate problem-based learning?
I have connection problem. I can't hear.
Yeah. One question in the chat box. Syllabus is very vast.
Okay.
How to incorporate problem-based learning? Even the class 2 students have around 10 to 15 lessons.
Yes. So basically you have to design and actually the lesson, for example, on pendulum, I always give the example of that. And pendulum has, in India, they teach only in one lesson. And they may show a already made, factory made pendulum. They may show or may not show, and they will say that, the time of oscillation depends on the length of the pendulum. And so that's it. But in America, in project-based learning, students design a pendulum, and right in the classroom, they do the experiment. And this is in 3 units. Number one unit that tells that there are variables in the pendulum. There are independent variable and there are dependent variable. Independent is the one which you can change. And in a pendulum, what are the variables which you can change? The mass of the pendulum is one variable. The drop of the pendulum, from where the length of the drop, you can increase and decrease. And there is another independent variable, which is the length of the string, and the string, type of a string, or could it be a solid stick? That could be, or it could be a metal, or it could be a thread. So all those things. And what are you looking at it? You are looking at a dependent variable, which is time. So this part is lesson 1. They do it and they will tell you that when they increase the length of the pendulum, the time of oscillation was different. This way, you don't have to memorize. I'm giving you an example. Your students are far ahead in the game. Each student will define in its own word. When it comes to English, they cannot. They have to memorize the definition. That's why I'm again stressing, let them do in their mother tongue, let them write them. They will interact with you so frequently, and they will ask questions, and teacher is there to answer their questions. Teachers are helpers to the students. So a project-based learning, this is one. In the second one, can you predict if the length of the pendulum is given? Can you predict the time of oscillation? That is the science. They will come to know, okay, they will do actually various sizes pendulum and draw a graph. And you don't give the length of a string, you don't give the length of a string of one, you give like, 10 centimeter. I'm just giving an example, 50 centimeter, 100 centimeter, 150 centimeter. And in between, we didn't do 125 centimeter. You have the graph, nice. And now you connect that and you will come to know what will be the time. And then what you do is you actually do this at that length, what will be the time, and you will be surprised your prediction was right. This is project-based learning.
Yeah.
This
Sir,
way.
one more question, sir.
Yes.
One more question in the chat box. Climate changes are great threat. Help us with some project.
Climate change
Are great threat. Help us with some. They are asking for some project in climate change.
Well, there are so many projects on climate change. You can do as many as you want. And, just simple observation. Climate change means environmental change, isn't it? And look at what happens, the crops. You can, and again, project-based learning requires time. I'm just giving you, when it comes to environment, the heat is producing the cracks bigger in the rocks. You know, I mean, you have to collect the data. Is there a crack? Okay, measure how much it is. And what will happen next year? Is that crack increasing? Or how much the rock was hot? Get the temperature. Science fair projects and project-based learning is collecting the data. What happens when you plant a tree in your school backyard? Is it changing the environment? Is it making your classrooms much cooler? All these projects takes months, years. Do it and find out. And once the tree was grown up, or the plant was grown up, became bush, how many birds are coming and resting on that? And is there any nest? And how many insects are crawling on the bark of the tree? And there were nothing before. There were no life in your, of course, nowadays, schools do not have gardens and playgrounds and all those things. Even your sports, you know. So these are the projects in environmental. You can do, and don't ask me, you come up with some projects.
Thank you, sir. Thank you, sir. Fine. One more chat box. They asked for the PDF of the presentation.
What?
I can. They want the presentation as PDF. Your PowerPoint presentation they want. It can be shared, inshallah.
Yeah.
All the presentation of webinar will be shared to the participant in the WhatsApp group, inshallah. And alhamdulillah, no more question. Now I request Dr. Nihar Akhtar, Joint Secretary of OMIET and the Education Director of Fatima Central Senior Secondary School, where the first science fair was conducted in 2008. Dr. Nihar Akhtar is a pioneer to bring the science fair to Chennai through OMIET. I request Dr. Nihar Akhtar to propose vote of thanks.
Excuse me, sir, can you hear me?
Yes, yes.
Sir, myself, Sabha Begum. Sir,
Okay.
my question is, in our school laboratories, we are having only compound microscope. In compound microscope, practically we can show the students in pond water only 4 microbes. The 5th one, for virus structure, they want to see it practically in the under the microscope. So we need electron microscope. In school laboratories, we can't afford it. What to do?
Electron microscope is it's very, very expensive and takes a lot of space, ma.
Yes.
We have only 2 in Chennai, one in Tharamani or somewhere, and one in Madras Medical College, which is not working. So you can just buy some foldoscopes. No, you cannot see virus in you cannot. I'm sorry, you should have made some background thing, research. It's not a simple thing. It takes the place itself is like, you know, one big room full. Okay, it's not a small thing like on a normal microscope. Okay.
No, I just want how to satisfy the student.
You can always show them
picture. I have shown
pictures, visuals. Yes. You cannot. Yeah.
Okay, fine.
One more.
Not possible. Yeah, it's getting late for Maghrib namaz, sir.
One more thing. Actually, not only Sabha asked one question. In case any experiment you are not able to do in your school, you don't have the sufficient instrument, you can approach any college nearby you and look for the any college where the required instrument will be available. Madam said the electron microscope is available in Tharmani. You can approach them and get their permission and take your student and you can do the experiment there. Any higher education institution, college will encourage any teacher in this kind of when you are showing the interest to guide your student, any request to the professor or any higher education institution, they will definitely oblige. Inshallah.
There was one more question which I would like to answer.
Yes.
One from Sister Nafisa. She was asking, there are so many lessons, how can we complete? Actually, project-based learning is very simple. They are not going to do it here in school. Most of the work is done at home. So if you plan ahead and properly do it, definitely you will be able to complete the syllabus. Syllabus is not at all a question. We've been doing that and we have always found time. Yeah. So
Thank
I'll
you
just
very much.
start. Yeah, I'll start my.
That's a good answer.
Yeah.
Yeah.
Yes.
Okay.
Auzubillahi minash shaitanir rajim. I'll start with my vote of thanks. Bismillah Rahman Rahim. The inspirational and motivational force behind science fairs in India, Janab Dr. Qazi Azher Saheb, office bearers of Umiyat, Dr. Peshmam Nazir, Dr. Abdul Kamal Nasir, Janab Mr. Hanif Khatib Saheb, Mr. SM Hanif Saheb, office bearers of AMP and members of Telangana Science Fair Committee, professors, teaching staff, and students and young scientists. Assalamu alaikum wa rahmatullahi wa barakatuhu. On behalf of OMIAT, I take immense pleasure in thanking our speaker of this evening, Dr. Qazi Azher Sahab, Assistant Professor, Michigan State University, USA. He has pointed out how to approach teaching, especially in the scenario of dynamic changes in learning theories. So we have to keep on updating and change the way we teach our children. So he has very beautifully explained to us what is project-based learning and what is how science fairs can help us inside the classroom, not only just understanding the concept, but also all the 21st century skills are involved in the scientific pursuit and the science fairs, starting from observation, analysis, critical thinking, and noting down the observations like statistics, and also in the end beautifully delivering it, presentation, and also communicating how they have done this science fair. So all the skills are incorporated in one single slot, that is short, that is science fair. So I hope all of you would take these things seriously and build our younger generation in the right way and make them all leaders. So this is, he has, Dr. Qazi Azher has given the first of the series of lectures preceding our 15th National Science Fair for schools and colleges to be conducted this academic year. I wholeheartedly thank my colleagues in OMIAT, AMP and Telangana Science Fair and all participants, professors, teachers and students from schools and colleges all over India. Hope we embark on yet another journey of discovery and creativity for the benefit of the human welfare and a better environment. Thanks for the opportunity. Jazakallah khair, sir.
Thank you, madam. Alhamdulillah, Jazakallah khair. With this, we bring the program to the end, and thanks to one and all who joined the program. Inshallah, we can meet again on 16th July for the presentation by Mrs. Shamim Raja, inshallah.